All right, this is the first of 3 video lectures that are asynchronous that replace Friday's lecture. Again, I apologize for not being present in class, but this should give you kind of the core information for what we would have gone over on Friday. So, today's topics are the issue of map projections and coordinate systems as they relate to map projections, that is a cartographic concept, and then analysis. And so what we're going to be doing is we're going to be moving through appropriate map projections, types of coordinate systems, and then how this, in the sense, is seen in the GIS environment. So again, what we want to think about from the standpoint of cartographic projections is, are we representing a map at a global scale, a continental scale, perhaps a state, if you will, or roughly the equivalent scale, or local? And then we're going to ask the question, when would we use different types of coordinate systems? And remember, coordinate systems are the aspects of the location that are defined by units. All right, so first of all, cartographic issues. And again, we always want to think the difference between, are we interested in a cartographic representation or are we dealing with an analytic representation? So the other thing to remember is all projections distort. Doesn't matter. The computer can calculate in unprojected units, but those are angular units. And so we always have to ask the question, how are we calculating? So from a cartographic standpoint, the 3 things that I want you to remember is that for most people, it is in fact the shape of phenomena that they read most accurately. In other words, the shape of Pennsylvania, the shape of the United States. We also have kind of a preconceived notion of what these things should look like. And any time that your cartography departs from that, you may get your reader to be somewhat suspect of what's being presented or be confused by it. The other thing that you really do need to be aware of is that if you have area distortion, you are in some respects misrepresenting area analysis if that's what you use. So again, we want to be careful with that. Okay, so what I'm going to do here is I'm going to walk through, from a cartographic standpoint first, some of the issues with the way that many people present data and the problems with it. What you see here is unprojected or geographic data presented in the ArcPro environment. And a couple of things should immediately come to mind. First of all, again, unprojected, so WGS is the datum, that's correct. And then the data itself is in angular units. And notice if you look down towards the bottom here, you see that it is, you can see the coordinates, the central coordinates in west and north. And so we kind of know where we are. But again, we also see that these units are in decimal degrees. Now, if we look at the United States, one of the things we see is it kind of looks funny. It's very flat across the top and it seems somewhat stretched out. This becomes even more problematic when we look at Pennsylvania. And again, I can't tell you how many times I see this representation of Pennsylvania, and it's a poor representation. Pennsylvania is stretched significantly. It doesn't quite look right, but it is, historically, it's kind of been the default in many GIS programs. And again, we have to be careful with that. It's a bad cartographic representation. We can make it better on different scales depending on what we want to show. This is kind of one of the classic representations of global data cartographically, and this is what's called the Robinson Compromise projection. That is, it's neither an equal area nor a conformal projection, but it's designed to do both of those things fairly well. And so you'll notice I've put just the United States on there, and you'll notice that it's pretty easy to tell what the United States looks like. We've maintained area and shape pretty well, but neither of them are maintained perfectly. The other problem, of course, in this case is that the United States is off to one side. Now that's perfectly fine if we're interested in the center of the map being Africa and Europe, but we can always change that central meridian. And here's what I've done on the next map. In other words, I've simply redefined the central meridian and brought the United States to the middle of the map. Where the center of a map is not necessarily the prime meridian. You can really make it anything you want. but we also have to be aware that what you put in the center is being presented as the most important element. And so again, we have to be careful about how we do that. The other way that we can deal with this, and this is one that we talked about briefly in class, is one that is now often used on web mapping programs, and this is what we call the Web Mercator Auxiliary. And what you'll notice again is that the northern boundary of the United States is still flat. In other words, it follows a parallel, as is Pennsylvania, but you'll notice that the country looks a little bit less stretched out. The Web Mercator is another form of compromise projection that works quite well on the internet, and in fact that's what it's designed for. Keyhole markup language, which is what is used in Google, uses this, and again, it's a good visual representation, but remember, it distorts, and so especially the farther north you go, the more the area distortion increases. So again, we have to be careful with that. But from a cartographic standpoint, it's certainly better than unprojected. Now, we can go a little bit further. We also, again, talked about this one in class, and this is kind of a best example of a continental scale cartographic representation. Most often when you see the United States, we see the United States with its northern boundary as an arc. And again, this is the Albers Equal Area USGS projection. So it is a projected, and again, you should be aware of this, it is a conic projection, and its two standard parallels run roughly through the kind of the northern portion of the continental United States and through the south of Texas. And so again, we have a limited level of distortion there, equal area that is, and things kind of look right. Now, the downside of this projection for us in Pennsylvania is you'll notice that Pennsylvania is kind of off to the right and that it sits at a canted or angled condition. And so again, if I'm going to kind of think about that, the question I always have to ask is that representation, I'm going to go back to it, the best that we can do? And the answer is no. We can get, if we're looking at the continental scale, the Albers Equal Area is a really good way people understand it. The shapes, the areas look good. It works great for cartography. If we want to look at just Pennsylvania, though, it's probably a good idea to use one of two relatively small scale projections for cartographic representation. One option is to use UTM, and again, we're going to get to what that really means in a minute, and actually the next video. The UTM Zone 17, which is what Pennsylvania is a pretty good, relatively large scale, that is small area, cartographic presentation. You'll notice that for the most part, Pennsylvania is horizontal. There's a little bit of an uplift here, and this is slightly off angle here, but again, it works pretty well. An alternative to that is, in fact, the Pennsylvania State Plain. And in this case, this is Pennsylvania State Plain South. And again, we're going to get to what that really means in the next discussion. But you'll notice that Pennsylvania is more or less straight across, and its shape isn't distorted. In other words, it's not stretched either way. So again, when we think about cartographic representations, we should always think about what looks right and what people will understand. Now, in the next discussion, we will be talking about the actual coordinate systems, and in those coordinate systems, we will look primarily at the projected coordinate systems of UTM and State Plain, but then we will also be talking about the Web Mercator and its coordinate system.